Economically speaking, how competitive is gallium nitride comparing with silicon or silicon carbide?
Yeah, so let me start with the cost, right? Because it all comes down to that. So anytime you have a new technology, you're competing with incumbent technologies, right? And the idea is you've come up with some new compelling advantages that make this new technology attractive. However, despite the additional capabilities, one of the main concerns is cost. Typically, people will want the extra capabilities with the same amount of money at the same cost, or they're willing to pay a small overhead for the extra capabilities, but not much. So with respect to cost, there's two things that need to take place. One of them, and that's really important, is to have mass commercialization, really volume production. And it's really the volume production that leads to economies of scale and reduces cost. So the question is, when you have a new technology, and obviously you're trying to replace something that's already there technologically, is there a big enough market to justify the expenses? So for GaN, that market is there because basically GaN devices are ideally suited for consumer electronics. So every laptop in the world and every cell phone in the world will have a power supply, and that power supply can be a supply that charges very fast. So fast charging because it's using GaN devices and because GaN will make the whole system smaller in volume and weight. Instead of carrying this big heavyweight brick for your laptop, you're going to have a very small, light type of power supply. So the first thing we need to point out is that with respect to the killer large volume commercial applications, GaN is already there. The second thing with respect to cost, there's always going to be a limitation to how cheap you can make the process. And the best way to make the process cheap, because you're competing with silicon, remember that, is of course to use the silicon infrastructure. So when it comes to using the silicon infrastructure, there are certain steps. First of all, it's the wafer, right? How does your wafer cost for the new material compare to silicon? The second thing is the fabrication. You're going to be fabricating devices. We know that silicon is massive in fabrication, right? Huge volumes, very streamlined, very cheap. How does your fabrication compare with that, right? And then the last thing, of course, is the assembly, testing, and insertion into the system, okay? So just to go through those really, really fast, with respect to the wafer, commercial GaN devices today are lateral, and they're using silicon wafers. So that's a huge advantage because the cost of the silicon wafer is very, very low, right? The second thing, of course, now is the epitaxy, right? That you do need specialized wafers because you're going to have heteroepitaxy, you're going to have GaN layers on a silicon substrate. So you need to grow a buffer layer. The purpose of the buffer layer in the epitaxy is basically to alleviate the lattice mismatch and help with the thermal conductivity. Now, the good news, fabrication, unlike silicon carbide, the GaN lateral HEMTs that are commercially available for power, basically in a way, I would call them a spin-off from the HEMT RF devices that have been fabricated for a number of years. So therefore, you have fully CMOS compatible fabrication. And that means you can go into big silicon fabs like TSMC in Taiwan and others and fabricate GaN devices really at the economy scale of silicon. That's very, very important. Okay, so you've got that. That's a big advantage. And then the last step is, okay, you made the devices, you want to put them in modules, in packages. That is going to be a lot more expensive. Why? Because GaN operates at very high frequencies. So there are a lot of considerations when it comes to the package. And very simply, silicon packages will not work for GaN. So you need specialized packages. But because of that CMOS compatibility, you can make integrated circuits in the GaN. And those integrated circuits basically provide gate drive, protection, diagnostic, and a lot of functions that help you out.